Here we have the Turnigy 9X. This is a computerized transmitter used on the SwitchBladePRO and SwitchBlade Style. It looks like there's a lot going on, but it's really not too bad. In the center, we have our on switch. Initialize this nice and quick. And then we have our primary controls are, of course, with a joystick. So we've got, on the left, throttle, yaw, roll, and pitch. Also known as throttle, rudder, aileron, and elevator. Now going through the switches, from right to left, we've got our timer switch, which hopefully you can see in the video. If I flip the timer, you'll see in the upper right hand corner a countdown timer that's configurable on this menu here. Once that reaches 0, it will alarm and let you know it's time to land. And as discussed in the battery, getting to know your Switchblade video, you'll learn about how setting up that timer can be advantageous to prevent excessive battery wear. I think you reset it here by holding the exit button. Yeah, there you go. So momentary, normally it's a trainer switch, but we're using it as a timer switch. It's momentary, so on timer, off timer, and then hold exit to reset. To get into the menu, you have to click and hold the menu button, and that'll get you into the menus. And you can look at the manual for, there's an enormous number of adjustments here. There's no time to go into it in this video, but the manual will explain all of them in detail. Exit to get back to the home screen. Now, like the 6X radio used on the standard Switchblade, we have digital trims, and you can see these little trim bars on the screen. So if you watch the one on the left, which is our throttle trim, you can see that little icon moving up. Now all of these Switchblades are flight tested, and the trims have already been tuned, so when you get them, they shouldn't have to do anything with the trims. But if you notice it drifting to one side or the other, you can bump the trims accordingly to keep everything nice and steady. Now, this knob here, it's called the hover throttle knob. It's linked to your APM, but by default it's unmapped, so it's not actually doing anything. It has functionality, but it's not doing anything. We did that because as you get more familiar with the APM flight controller on the Switchblade, you may want to use it to adjust parameters dynamically while you fly, and this knob can be mapped to any particular parameter you want to adjust. So instead of doing countless lands and takeoffs to change parameters, you can program a range of one parameter and then adjust it on the fly so you can see how it affects the machine. These two switches, this one here and this one here, this is normally a gear switch, but we're using it as a flight mode switch. Now unfortunately this transmitter doesn't have a single 6-position switch to go through all 6 flight modes available to us on the APM. So we're going to use these two switches. One is a 2-position switch, this one here, and this one is a 3-position switch, together to create the 6 potential options. Now for your convenience, we've printed a little reference guide here to tell you each switch position's function, just in case you forget. But run through them here real quickly. First off, let's mention this is in the default switch position, and this is something you want to memorize. All of the switches are either back or down. That's the default switch position. The knobs are all centered, although those don't really matter much. And we do this because you want to be confident that everything's in the right configuration before you take off. And so by default, these flight mode switches are back and down, and that is what we call down and position N, because it's labeled here as N12 in that order. So when this is down and this is in position N, you're in the stabilized flight mode. This is the easiest to fly, 100% manual flight mode. When you move this switch to position 1, from N to 1, that'll put you into loiter mode, or a 3D position hold. Now this function is very handy and is great. However, it is completely dependent on GPS. If you lose your GPS or you have a weak GPS signal in flight, it will no longer stay in one position and it will drift around. You should not use this until you're completely comfortable flying manually, so that you have the potential to take over flight at any moment in the event that GPS is lost. If I move it into position 2, that is the altitude hold position. Now this one doesn't use GPS, and uses the onboard sensors, primarily the barometric pressure sensor, to keep you at one specific altitude, and it's actually quite accurate, or at least my experience has been. This we may use during training, and we'll go on to in some of the other training videos. So if we go back to position N, and then we move the other switch up into the up position, now this activates what's known as auto mode, which is the language used for to execute a mission. So if you go onto your computer, you program a flight mission, you download that mission to your APM flight controller with your USB cable. When it comes time to execute that mission, you get everything armed, ready to go, and then flip into auto mode. And now you have an autonomous craft flying its mission. If at any point during that mission you want to take over, you simply flip it back to stabilize, and now you're back into your 100% manual mode. The next flight mode is this switch in its up position, and this one in the 1 position. Now if you put it into this configuration, it'll enter its landing sequence. Now it's not GPS dependent, it will simply land wherever you flip those switches. So up and position 1, the craft will go through its landing cycle and land. Now this is kind of a handy function, don't use it terribly often, but you want to be certain that whatever is underneath the craft can be landed on. So if you're in a big grass field, hopefully with short grass, it's perfectly fine to use. However, if it's near tall grass or cars or power lines or anything else, it's just going to land on it. It doesn't know any better. So you want to be very careful using the land function. Now the very last flight mode that's default programmed is this switch up, this switch into number 2 position. This is the return to launch function. It's pretty fun. It does use GPS, and by default it will command your craft to fly or immediately increase its altitude to 15 meters or decrease if you're above that, wherever it's at. Once it's at 15 meters, it will move back over to the launch position, and the launch position is defined as the location by which the GPS first got signal. So when you set it on the ground and you plug in your battery, that's your launch position. Now if that happens to be inside your living room or in the back seat of your car, it's going to try to land on the roof of your car or the roof of your house. So you want to be very careful and realize that when you command it to return to launch, it's returning to wherever it initialized. So if for some reason you've lost orientation and you want to get it back, you can always take over manual control by simply switching these back to down and to N. That puts it back into stabilize or your fully manual mode. Okay, second to last, we have the dual rate switches. That's this one here, and this one here. This is rudder, elevator, and aileron. So this one commands this stick, this one commands this stick, and this one commands this stick motion. Now by default, there is 30% expo programmed into each joystick motion. The rudder or yaw, the elevator or pitch, and the aileron or roll all have 30% expo. Now let me, through the magic of video editing, pull up a picture of what an expo graph looks like.
Here are 2 screenshots from the controller itself. On the left we have 0 expo, which is the bottom number, and the horizontal or x-axis is correlated to the motion of the joystick, while the vertical or y-axis is correlated to the control input to the aircraft. Now on the left with the 0 expo, you can see it's a linear correlation, whereas on the right we have 100% expo, which will soften the amount of control input to the aircraft around the center of the joystick. And we'll demonstrate that here in the video.
Here you have 30% expo, and all this does is make the fine motion around the center point of the joystick a little bit more kind of spongy, if you will. A small stick deflection, or a relatively large stick deflection, let's say 5-degree joystick deflection, will correlate to a smaller control input for your aircraft. And this is typically favored by novices because they get a little more gross motion for a relatively small output on the craft. The reason why we programmed them with 30% is because it's kind of a middle ground between soft center function and still good control. But as you get more experience and you want a little more aggressive, a little more tight flight controls, you can simply switch these down for whichever axis or all axes. And now you'll have 0 expo. It's a perfectly linear correlation between joystick motion and craft control. So it'll tighten up that feeling around center, and you'll get a little bit more fine control. So we'll move those back into their default positions. This is also all adjustable through the menu here, and you can read about that in the manual. Okay, and lastly, we have the throttle hold switch. Now you want to be very careful because this can be a kill your craft switch if you're not using it appropriately. In its default position, it's back. That is an unlocked throttle. You can use your throttle just like you normally would. If you move the switch forward or into the up position, now your throttle will always be at 0. No matter where the joystick is positioned, the craft sees 0 throttle. The reason why we put this in here is that when it's on the ground or if you're in a crowd, it gives you the security of knowing, okay, my craft is locked. This controller will not make the props turn. Now there is a separate protocol to arm the craft that we go into in later video instructions. So the APM does require an arming procedure to work. But in addition to that, we added this throttle hold just to make certain that even if it somehow got armed, it still can't be activated. That said, it is a nice safety feature, but you want to be certain that this switch does not get activated during flight. If you flip this switch during flight, it's exactly the same thing as bringing your throttle to 0. The props will stop turning and it will fall out of the sky like a brick. If by some chance you do bump it, simply turn it back off and bring your joystick back to its position and recover the craft. This switch needs to be avoided during flight at all costs. Honestly, my favorite use for this switch is it's a buddy prevention switch. If you have friends around that think they know how to fly it and you really don't want them to know, you can flip this switch and nothing they can do, unless they happen to know about that switch, will allow them to fly your craft. That is the quick overview on the Turnigy 9X radio.